Hello all, welcome to another session of Python for Data Science. Today we look at a few concepts of functional programming. We will also look at concepts of scope in Python. So basically what is local scope, what is global scope, we'll basically look at all of that. So initially we'll start off with few functional programming methods. The few common functional programming methods are: one, you have your map. Then the other common one is something that's called filter. Then the other one is something that's called as reduce. So map, filter, reduce. Now I think this has become very famous mainly on account of your distributed computing. Your Hadoop ecosystem, all of it works on the same idea. You basically map, filter, and reduce. But today we'll look at it from a Python standpoint. So we'll start off with map. So what is the idea? What is the idea of map? Right. So from the name itself you're basically trying to map something, right? You're basically trying to map something. Mapping, again, you're just trying to make a sort of one-on-one, right? It's basically trying to apply or map or some function to another, right? So this is a list. So what does map does is, so one easier way to think of map is, you can basically apply a function to each element of this array. So instead of writing a loop, instead of writing a for loop, map is one easy way. Map is one easy way of getting this output. So for using map, obviously we can use your normal def function form, right? Or you can also use the lambda and the single line of functions, right? So the format for map is, the initial one should be the function. So in this, say I'm just squaring it up, followed by my list. Now what happens when you run this is you basically get a map object. Now in order to get a sort of list object, basically what you have to do is you basically just need to run a list of map of. Now you get your list object. So basically the idea is you're just sort of applying a function to each and every element of the array. So that's what map does. So now we'll move on to filter. So filter, right? So from the name again, filter, basically you're sort of applying some sort of condition, right? You're sort of applying a sort of condition over there, right? Filter, right? That's what the name is, filter. You're basically filtering the input data on the basis of certain condition, right? So condition could be as simple as, say I'm just taking the modulo of, so I'm just only trying to get the factors of 4 maybe. So this is a condition. So one easier way to understand this is, so it's only looking for this particular condition. So whatever element satisfies this particular condition, it gets printed out. Right? Again, the idea is similar. You pass a list, you wrap the object around the list. Why? Mainly because you basically end up getting a filter object again, which you do not, it's good while you're looping and stuff, but in your normal this thing, it's better you just wrap it around the list. Right, so this is what filter is. You basically apply a condition. You apply this condition to each and every element of the array, and it filters it out. So next, basically what we move on to is reduce. So reduce is actually not in the built-in functions in Python. So you basically need to import it. You basically need to import it from the functools library. Again, this thing is the reduce is basically what we do is you sort of maps function, right? Filter sort of filters it. Reduce it, so basically you're just reducing it. If you have a sort of bunch of elements, you basically reduce it to a single element, or depending, again, it depends on whatever you're trying to apply. So in this particular case, what we're doing is we're sort of iteratively adding elements, right? So I basically have my reduce. Again, the format is very similar. you write your functions. You write your functions in the beginning, followed by the data this thing which you're passing. So reduce lambda of xy is to x plus y. So this will close this, then followed by my list. So this is sort of a cumulative sum. So in this you're passing a sort of cumulative sum. Okay, this looks to be some sort of error. So now in this, say suppose you pass this lambda of xy, so x plus y, basically you'll get a my list, right? So you're basically trying to get a reduce. So this one is only for lambda. Now we need to just close it. This should work. This is 120. So again, you're taking the sort of cumulative sum. This is map filter reduce. Obviously, you can use a sort of a for loop for this also. Instead of just writing a map, you can use you can use a for loop to take care of this. But a for loop will also take care of this. Okay. Next, basically, we'll move on to function scopes. Scope, namespace, and all of that in Python. So Python basically has something which is called as local scope and global scope. So it's so what is the basic idea behind that is so you have a, suppose you write a function. Okay, so you write a function over here, and you have I which is inside the function. So basically, what is the idea? What is the concept over here is whatever I is there, right? I can only be accessed inside the function. So basically, the scope of I is only inside the function. So you cannot access whatever variables are inside the function outside as well, right? So we'll look at it through an example. Okay, so this is one you're just printing it out. So I is equal to 5. So you just define the function over here. Now say now you've defined the function. Let's run this. So you basically have the function over here. You just call the function because you have print statement, you get the output. Now when you try to access I, what you get is you immediately get a name error. Why? Obviously because I is not defined. Basically I is not defined because I is the scope of I. It is restricted to only inside the function. Now let's take a case where we'll copy this. We'll copy this. Now we have a I in the outside. Okay. Now when you actually call I, what will happen is you will get the output. Why? Mainly because whatever I you have written outside, right? Its scope is sort of global scope. It can be called in any place in this say in this particular Jupyter notebook. It can be called at any place because the scope of I is now global. That particular I which is written over here, obviously, like this particular I. This I is say again instead of I. Now say just for confirmation, I replace I with J. Right? I get the I. Now I get the J. Let's say I just type in J. It will not throw because it will not give an output because its scope is restricted. Now, so what do you do? Now, so there could be a case where you're basically updating something inside the function, and say suppose you want to access it outside the function, right? So how do you do that? In such cases, basically what you have to do is you basically need to use something which is called as global. You basically need to use a keyword called global, and through that keyword global, it basically sort of you can access outside the function as well. We'll look at a few examples to make this idea clear. So basically you have your local and global scopes as well. Yeah, let's look at an example. So in this particular case, you have a variable. Say you have a variable called global value. Right? Now, basically, what you do is you basically define a function. Right? Now, basically, what you're doing, you are sort of printing the value. So now, where is now you will be able to access this var. right? You will be able to access this var, because this var is sort of a global listing, right? It is accessible to all functions, so you will be able to easily access it. So the other way around is not possible. So suppose you have var inside the function, right? And you print the value of var, it will not work. This one will work, right? So you can't have a list over here. Yeah, right. So I'm just printing out var is. When you run this, you will not get any error, because since var is defined outside, it's sort of this thing, right? Now, say suppose if you actually try to do the other way around, you want to do it the other way around. Basically, what you do is, so let's look at through that as well. Now, say suppose let's use var underscore one, because var is already taken, so you might actually get some, you might not actually get some value. So this is var underscore one, print var is, you basically have your var, you basically have your underscore. Now we'll run it. I think you should be able to get it clear. See right now the immediate, so whenever you run the print statement, whenever you run the print statement, immediately it throws an error saying var underscore one. Var is also the function. So how do you overcome this? One way to overcome this is you basically define this to be global. So global is the keyword. So you just basically say global of this thing. Now it will run, because this is exactly same as this one. Because whenever you write global, it basically means you can access it outside the scope of outside the function also. That's what it basically means. Right. Now, say suppose we'll consider a case where one more variant of this. Say I say var is equal to 1. Again, I'm writing a function again, def function. Var is equal to var plus 1. I'm just adding this var. Now again, print var. Now what we'll see is var inside function. Now again, it's similar to your the previous, what the other ones which we have did. Inside the function, just print it and run it. Now you immediately see, right? You get an error, right? So it's like local variable is referenced before assignment, right? So what happens? What happens now is the normal listing gets executed, right? You basically get an unbound local error. The normal listing gets executed. Where inside the function. Now basically what you're trying to do is you're basically trying to change this thing, okay? But what has happened is var is basically a local listing, but since you haven't called it inside the function, you're basically trying to change it to local. That's why you get a unbound local error. So it's not basically bound, so it's not basically in local. Fine. So this is what the idea is. You can directly call any output variables inside the function as long as you don't change it. In this particular case, if you can see, you used var perfectly fine, but if you're trying to try to do any sort of operation on it, that's where things get problematic. Okay. Just to give you just to give you one more of say local, just to give you one more of example of scopes, right? So I basically have a var, right? So you basically have global var, and then you basically have outer, right? Now it's all the same. So it's enclosed. It's enclosed. It's enclosed within the function. Okay. It's enclosed within the function def inner. Def inner. Right. So basically, I have outer function. Then I again have inner. Now basically, what I'm doing again, I'm changing it. So this is sort of function within the function sort of this thing print var. Then basically what do we have is we have inner. So now we are basically calling this inner, then again we are calling this outer at once. Right now what do you think would be the out? Right, what would be the output? So this is like basically a function, even though you have var, right? Even though you have var and you're sort of calling this function. So whenever you call outer, since you have a print statement, it returns output. So the output, the whatever value you should get now should be local val. Right? Yeah, so it is local val, right? So this is what this is. Now basically you can basically make it non-local as well. Non-local as well. What do you mean by that? Is it's not specific to your local val. There's a keyword. Basically, there's a keyword called non-local, which you can use it as well. Again, just to give you an example to make non-local clearer. This is your global val. Fine, you're defining an outer function. So your val, say now you have global. Now you are. So now you basically have your local val. Now you're writing a print statement. Print. Before. So you got a print statement right now. Okay. Now you are defining your inner function again, same as the previous example. Now in this, what you're doing is you're adding a keyword called non-local. So this is a keyword. Again, what is a keyword? A keyword is basically telling you sort of reserved built-in words in Python. That's what keyword means. Non-local val, again, I am changing my val to, right, I am changing my val to inner val. I got my val. I am printing it as well. Print inner val. And now basically what I do, I call this function. Now after all of this, so this is like after you print output. So this is outer before and this is outer after. I'm again printing it. The basic idea is you're seeing what happens after you run all of this. Right now you have the function which is ready. Now just when you call this, you just call outer. See, in the first example, right, val was a global val, outer before local. So it's like outer before when you look at the first output, it says first output, local val, because inside this you've done this. Next, when you go to inner, that function inner, print inner val, and because you're making it non-local. So since you're making it non-local, you can basically change it without getting into errors, which we saw over here. Fine. So we are only inside this. When you go outside, so when you come out, this thing, you still have this only. Now you have done this. Now when you print val, you get this global val. Why is that? Basically, so since you're only inside this function, all the scope is sort of restricted to this inside only. Then you can have maybe a built-in scope as well. Then there's an option for that as well. But for now, we'll stop here. Thank you guys. We'll again meet in the next class.